All righty, folks. How you all doing? Back for one final day of matrices. Now, I am going to throw on a couple algebra topics um, on if you wanted to look at them during Christmas break. So there are a couple things we didn't talk about as far as matrices go. Something called determinants and Kramer's rule, but you'll be able to catch those later if you want to. If you'd like to, if you've enjoyed matrices and you want to know a little bit more about them. But we're going to get into this idea of an inverse matrix. Now, inverse matrices, they help us out a ton when we deal with solving equations. So in solving a system of equations, for instance, if you have this little, you guys kind of see this little notation up here, right? This has a to the 1. Remember what happens when we multiply numbers with the same base? You just add their exponents. So a to the 0 and a to the 0 is 1. So an inverse and a regular expression, they end up canceling each other out and make it 1. So we are able to actually solve things. So this is essentially that idea of what we're going to be doing here today. But before we do, we are going to talk about a few things. So that's going to be where we end up. But in order for us to get there, we need to talk about a couple things in general. The first thing is called an identity matrix. Identity matrix. So identity matrices, these are matrices that are square matrix. And what I mean by square is that there's the same number of rows and columns. They have the same number of rows and columns, but they're all ones and zeros. So an identity matrix is a matrix. So here's would be a 2 by 2 identity matrix. Notice they're really close to our row reduction. Remember what we called this? We said this was called row reduced echelon form. So an identity matrix is essentially the result you get when you get to that row reduced echelon form. Well, that's going to come into play here in a second. So, because we are going to do a little bit of row reduction just to kind of show how this works, but we're ultimately going to use our calculators on this. But notice, it's not just the zeros underneath the one. We are going to go all the way through and make zeros on top of the ones. These are identity matrices. If two matrices are inverses of each other, they're going to multiply to give us essentially the identity. One is the multiplicative identity. Whatever you multiply by 1, you get itself. Well, these matrices, whatever you multiply a square matrix by its particular identity matrix, you get the same thing. If two things are inverses of each other, they become the identity matrix. So our first problem here, show that B is the inverse of A. That B is the inverse of A. So what we're going to do here, friends, to show that B is the inverse of A, we are going to multiply straight across, okay? So we're going to take the rows of our first one, and we are going to multiply it by the column of our second one. So B is the inverse of A. In other words, we're going to go B times A. So you guys are expert multipliers now at this point in time. So why don't you guys go ahead and multiply the two things together? Go ahead and hit pause while you multiply them out, and then I will come back and do it as well. All righty, good luck. All right, so you guys are back now. Let's take a look here. Let's show that these actually are inverses of each other. If they're inverses, they should end up becoming the identity matrix. So we're going to take the rows of the first one and multiply by the columns of the second one. So let's see here. My row of my first one, I have a 1. And I have a -2. And there are 2 columns, so I'm going to write this twice. And again, you guys are expert multipliers now. So you know exactly how to do matrix multiplication. So if I plug them in there, let's see here, we got -1 and -1. Right here, we would have 2 and 1. Then we're going to go and do our second row. So we have 1 and -1. And we have 1 and -1. So our second row is going to be multiplied by our columns of the second matrix. So -1 and -1. We have 2 and 1. And if these are actually inverses of each other, I better end up with that identity matrix. So we have -1 plus 2. We have -1 plus 1. 2 minus 2. And 2 minus 1. And friends, they really are the identity matrix. And that's what we're looking for here today. So when we're solving different trig or different matrix equations, we want to create the identity matrix on one side to be able to get our variable or variables by themselves. So that's going to be kind of the goal for the day. So we're going to look at, first of all, how to find an inverse matrix. I'm going to show you the actual reason behind it. But like I said, for an inverse matrix, we're going to go ahead and use our calculators. Although we will ask that you guys do know how to do an inverse matrix of a 2 by 2 using the formula. But I'm going to first show you how it comes going the long way. All right. So now when you're trying to get an inverse matrix, it's all about row reduction. So remember when we did our augmented matrices? Yeah, that's what we're going to be doing here. So when we're dealing with augmented matrices, the whole point for inverse functions is to take the identity matrix from the right side, and we're going to use augmented matrices to make the identity matrix go from the left side. So if you notice, we're going to start off with the matrix on the right side, the identity matrix, but we're going to do row reduction until we get it to switch sides and get it on the left side. So good news here with my row reduction. Thank goodness, I already have a 1 here, so this is already going to be a little bit easier. So I'm going to, remember my 3 rules. I'm going to add my first row to my second row and replace the second row. So row 1 plus row 2, we're going to just add them up here. So when I do that, this row stays the same. So now I have to make 1s and 0s kind of pop up all over the place. So 1 plus -1, that would be 0. So that's what I'm changing right there. I got 4 plus -3, 1. Thank goodness I got a 1 there. So this is going to actually not be so bad. So we're going to actually get through this one fairly quickly, which is nice. So since I already have my 1 here, that's pretty nice. I only got to do one more row reduction, looks like. One more operation. So I'm going to take that second row and multiply it by -4. And I'm going to add that to the first row. If we were doing the Gauche Jardin, we would be already done. But remember, we got to get it in full row reduced echelon form to get our inverse matrix. So 0, 1. I'll get a 1 and a 1. And what did I get here? So 0 times -4 is 0 plus 1 is still 1. I get a 0 there. Notice I now have my identity matrix on the left side. So whatever's on the right side, that would be my inverse matrix. I end up with a -3 here and a -4 here. So that means what we came up with here is we're saying that the inverse matrix to A would be -3, 1, -4, and 1, or saying that's the identity matrix. Well, there's one way to find out. You multiply it together. So let's take the identity matrix and let's see what happens when we multiply it to our original matrix. So friends, we're taking our inverse matrix. Notice how the inverse always goes in front. And we're going to multiply it by the regular matrix. And we're saying that this should hopefully, if we did this right, this should become the identity matrix. Why don't you guys go ahead and multiply those out? Let's see what it becomes. All right. Remember, we're doing rows of the first one times columns of the second one. So -3 plus -4. And then we have -3 because we got 2 columns times, and then we have our -4. And we get 1 and -1. And we get 4 and -3. So the first thing we got to be able to do today is come up with an inverse matrix. We have 1 and -1 here. And we have 4 and -3 here. So let's see what we end up with then. We get a -3 plus 4. Oh, I can see my 1 showing up there. I got a 0. Oops. I get 1 minus 1. I can see my 0 showing there. I can see a -12 plus 12. I can see my 0 coming up there. And last and certainly least, I got a 4 and a -3. So friends, I would say that these are indeed the inverse matrix. So 1, 0, 0. No, I'm sorry. They are indeed the identity matrix. So therefore, those two had to be inverses of each other. So one matrix would essentially cancel out the other matrix. But something kind of cool that comes up is this idea. There's a shortcut for doing 2 by 2s. Although that was a pretty short row reduction there. They're not usually that short. And it's basically just knowing a little formula based upon where our ideas are. Notice the D and the A. Notice what happens to the D and the A. They just, not the color I wanted. They just switch sides. And then also notice my B and my C, they just get a negative thrown in front of it. So the D and the A, they flip-flop, and the B and the C, they get a negative. And then you're going to have a scalar multiplication out in front. 1 times AD minus BC. So let's see how that would have worked if I would have came back and done that for my original matrix. So if I would have taken A and done the inverse at the very beginning, it says, first of all, 1 times AD, so 1 times -3 minus B times C, so 4 times -1. So we got that part. And then what happens after that? The A and the D switch sides. So the 1 goes down here, and the -3 it would have gone up here. And then the B and the A would have got the different signs. So -1 would have became a +1. +4 would have became a -4. And if we did this right, we should have ended up with the same exact matrix. So 1 over -3 plus 4, which is just 1. So 1 times this whole matrix, well, I would have ended up with what I originally had. And that's kind of a cool little thing that happens with 2x2s. So we have this little shortcut we can use to help us get the same thing we would get for a 2x2. So let's have you guys try one more 2x2 as we're really filling up the screen here. I kind of like it. It looks fantastic. Using this matrix right here, let's do 2, -3. And let's try -5 and 4. Do me a huge favor. Why don't you guys go ahead and figure out what the inverse matrix would be for that matrix? What would be the inverse matrix? All right, let's see how you guys did. All right, so hopefully you paused the video and you tried it. So 1 over 2 times 4, so A times D, minus B times C. Okay, so we do the scalar part, and then we're going to take our A and our D and we flip them. And we take our B and our C and we make them have get the opposite sign. So -5 becomes a +5. -3 becomes a +3. So I end up with 1 over 8 minus 15. Oh, this is getting ugly, friends. Getting ugly. So we have -1/7. So let's bring this down. And now when we throw in our scalar into it, we get -4/7, -3/7, -5/7. These are all 7s in the denominator, by the way. And -2/7. And I want you to see something here. That right there, friends, is an ugly, ugly, ugly answer, right? But if we use the formula, it comes out pretty nicely. If I would have had to have done row reduction on that one, I would have been playing with a whole lot of fractions and I would have just been unhappy. So realize that sometimes, or not sometimes, always, all the time, that little formula for a 2x2 will work out and we'll save ourselves a little bit of a headache. So Ms. Hodge and I, we are going to ask that you guys know how to use the formula for a 2x2. But the rest of our matrices, you don't have to do row reduction on, but you should know where it came from, which is why I'm showing it to you. We'll have you guys use your calculators on that. All right, we're going to keep going though. Find the inverse matrix. Oh, so again, find the inverse matrix, friends. That is not going to be the most enjoyable thing in the world. But here we go. Let's try it. At least for the nice part here, for me, I'm going to go ahead and do row reduction so you guys can see where the inverse matrix comes from. And if you notice, there's a 1 right there, right? So the nice part about that is I don't have to do quite as much there. So let's see if we can't figure this out together. So for my first one, I'm going to go ahead and do my row reduction here. I'm going to multiply row 1 by negative, and then add it to row 2 to replace it. And if I were to do that, friends, so I still have my 1, my negative 1, 0. And remember, we have that other part here because we are technically starting off with the inverse matrices. We're going to make an inverse matrix show up. I want you to see how it works with a 3 by 3, but then after that, you guys will not have to generate it by hand. I mean, you can, I guess, but you definitely don't have to. All right, so let's see here. If I take my 1, multiply by negative 1 and add it, I get a 0. I get a 1. I get a negative 1. Well, this would have been, this row right here is 0, 1, 0. So negative 1 times negative 1, that would put a negative 1 there. I would have had a 1 there and a 0 there. That's the only thing that would have changed. All right. Let's keep going here. Let's get rid of my third row. So I'm going to take row 1 and multiply by negative 6. And then add it to row 3. Let's go move my head, move my dome. I'll go right in the corner there. All right, let's see here. We got 1, negative 1, 0. Whoop, 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 whoop. There we go. That's the intelligent sound to make, friends. That's a sound that something good is happening. 1, 0, 0. I got 0, 1, negative 1, negative 1, 1, and 0. All right, now I'm multiplying my top by, so 1 times negative 6 plus 6, that'd be 0. Negative 1 times negative 6 is 6 times negative 2, that'd be 4 here. And negative 6 times 0, 0, and I have a negative 3 here. All right, so we're just cleaning things up here a little bit. Just cleaning things up. Negative 6 times 1, that makes a negative 6 down here. 1 times negative 6, I'm going to get a negative 6 right there as well. Oops, that's a 0 there. I'm sorry, that was my ugly 0. And I'm going to get my 1 right there. All right. So again, what do we got here? Nice thing about this is at least I do have a 1 right here, so that's going to kind of help things, speed things along. So now I'm going to start getting zeros above and beyond it. So I'm going to do a, oh, that would have been bad. Use that. Let's try that. All right, I'm going to add row 2 to row 1 and replace row 1 this time. So I have a 0, I have a 1, I have a negative 1, and I have a negative 1, I have a 1, and I have a 0 there. Underneath it, I have a 0, a 4, a negative 3, and then I have a negative 6, a 0, and a 1. There we go. All right. So we're going to multiply, we're just going to add row 2 to row 1 and then replace row 1. So 0 plus 1 is 1. Notice how that never changed. 1 plus negative 1, 0. So we're doing a full row reduced echelon form on this one. Negative 1 plus 0, that makes that a negative 1. Negative 1 plus 1, that makes that negative 1 plus 1, that makes that a 0. What do we have here? 1 and 1, that makes that 2. That's a 0. I keep thinking that I really got to fix that because that is a 0. There we go. 1 plus 0 is 1. And 0 plus 0 would be 0. All right, so even that one doesn't look right. So we got 1, 0, negative 1, 0, 1, 0. All right, now we're going to keep going here. And I'm going to multiply negative 4 times the second one. So we're doing this once, so that way we don't necessarily do it again, but we appreciate what our calculators are going to do for us here. And I'll show you how to use your calculators here in a second. So we got 1, we got a 0, we got a negative 1. And we got 0, 1, 0, 0, 1, negative 1, negative 1, 1, and 0. We're getting really close here now. All right. So that 0 times negative 4, 0. 1 times negative 4 is negative 4, plus 4 is 0 again. Negative 1 times negative 4 is 4, plus negative 3, that's a 1. Love how these ones are showing up here for me. Makes it a little bit easier. All right, and negative 4 times negative 1 is 4, plus a negative 6, that's a negative 2. And 1 times negative 4, that'd be a negative 4 right there. And we still have 1. All right. So now we're getting somewhere. We're getting a little closer here to being at the end of this thing. So we have 1, 0. I should probably erase that because now we're playing with our second row. Again, we already have the 1 there. That really makes it helpful. So how about we take our third row and add it to our first row, and we'll replace our first row. So row 3 plus row 1. That's what we're going to add together here. So essentially, row 3 is done. 0. Won't be touching row 3 again today. Negative 2, negative 4, negative 1. And we'll deal with the second row here shortly. All right. So what do we got here? 0 plus 1 is 1. 0 plus 0 is 0. 1 plus negative 1 is 0. You can almost see how we almost have that fully row reduced echelon form on the left side. Negative 2 plus 0, that'd be a negative 2. Negative 4 plus 1 is a negative 3. And 1 plus 0 is 1. So we got one more to go, friends, one more to go. And then I think we will have our inverse function, our inverse matrix. I keep saying function, matrix. So now this time we're going to take our third row and add it to our second row. And what we're hoping is that we have a matrix that looks phenomenal. All right, so I'm done with the first row. So 1, 0, 0. I'm saying the first row is going to be negative 2, negative 3, and 1. And you're going to see, essentially, friends, why we don't want to necessarily be using this all the time here. It takes forever to create that matrix. All right, so 0 plus 0 is 0. 0 plus 1 is 1. 1 plus negative 1 is 0. Hey, this is it. Negative 2 plus negative 1 is a negative 3. Negative 4 plus 1, that would also be a negative 3. And 1 plus 0 is 1. So friends, what we're saying then is that right side, that would essentially be our inverse matrix. I guess the question I have is, do you believe it? Do you believe that these are inverse matrices? Because if we can prove it, we can move on to the last thing, where we actually are going to use them. So I'm saying and suggesting to you, friends, I believe that is the inverse matrix, that original function. So I guess the best thing for us to do to be able to prove it to ourselves is to multiply it. So let's go ahead and let's try multiplying all that out. Are they actually inverse matrices? And if they are, then we'll go on, we'll learn how to do it on our calculator real quick, and then we'll use it to solve systems, which is really what we wanted to do today. You're like, we haven't even got what we wanted to do today? No, not yet. So -2, -3, -2, -3. So we're going to take our first matrix, -3, -4, 1, 1, 1. So we're going to take the inverse matrix and we are going to multiply it by the regular matrix, 1, 1, 6, -1, 0, -2, and 0, -1, and -3. All right, friends, here's what I'm going to have you guys do. You are going to literally one final multiplication problem just to really make sure we fully got it. Why don't you guys multiply the inverse by the regular matrix, and let's see, what is it the actual identity matrix? Go for it. All righty. So every row by every column, every row by every column. So 3 rows by 3 columns. I will end up with a 3 by 3, so that's good. I'm going to multiply -2 by this first row by the first column. So let me get it set up here. There's column 1. Here's column 2. And here's column 3. Ooh. We're doing lots of work here, folks, to prove to ourselves that we actually agree here. 1, 1, 6, -1, 0, -2, and then 0, -1, and -3. In my mind, I don't mind you guys using your calculators. Obviously, my master's thesis was on calculators, so I'm a big fan of calculators. But before we do, we have to make sure that we understand why. Why do things work the way they work? If all we do is we just believe what everybody tells us, we're not thinkers. We're not going to seek to make improvements on those things we see around us. We want to be thinkers. So now I'm doing the second row by every column. I told my wife before I made this last one, this will be the last one I make today. I said, this one's going to be a long one. All right, let's see. We got -1. Oh, I lied. It's a +1. +1 and a +6. And then we got a -1, 0, and -2. And then we have 0, -1, and a -3. And then our last row. It's a -2, -4, and a +1. -2 times a -4 and a +1. -2, -4, and a +1. All right, let's get those last columns back in there. 116. Again, we just got to be really organized when we do our matrix multiplication. Again, it's not hard. It's just organized. You're going, Williams, you had us multiply a 3 by 3. Yeah, I did. But you guys doing it one time is not going to hurt you. Yeah, but it's painful to watch you do it. Okay, that might be true. All righty. So when we multiply out the whole thing, does it actually work? So what do we have here? We have a -2, we have a -3, and we have a +6. Oh, I can see one showing up there. We have here -3, -3, +6. I can see a 0 there. -2, -4, +6. Over here, we got a 2, we got a 0, and we got a -2. We got 3, we got a 0, and we got a -2. We have a 2, we have a 0, and we have a -2. We have a 0, we have a -3. Oh, is that a -3? Can't read my own handwriting. Yeah, it's a -3. No, that was a +3. I'm sorry. And then we have a -3. All right, we have a 0, we have a +3, and another -3. We had a 0, we had a +4, and a -3. And friends, when you go through and you add up every single little term, I believe we end up with the 3 by 3 identity matrix. Which tells us this was actually, they were matrices of each other. Now, I'm not going to ask that you guys do this again. Okay. Again, this is just for your well-being. You need to know that you know that you know that it does actually work. So for us, it's how do we go ahead and make this a little bit more user-friendly so we can actually do all this stuff. Well, that's where our calculator, the explorers come in. All righty. So how do we use our calculators to do inverse matrices? To begin with, you guys are going to first go pause if you need to go grab your graphing calculator, but go grab it. All right. So our first thing, here you go. You are going to type in second and the -1. Notice how the -1 is actually going to be grouped with the matrix button. Interesting. It's almost like it was inviting you to do it. All right. So once you're there, you're going to see 3 columns. You're going to see something that says names. We don't want that one. So you're going to ignore that one right now. You're going to see math. You only do that one if you want to have your calculator do row reduced echelon form. You'll find it underneath the math column. So it will solve everything for you there. and then the edit. So we're going to go to edit, and we are going to, on number 1 where it says A, you're going to go ahead and make sure that's highlighted and press the enter button right next, enter button while it's highlighted. And that's going to take you to a new screen. It's going to take you to a screen that says this. It's going to say matrix A, and it's going to say 1 by 1. Well, we clearly don't have a 1 by 1 matrix. We have a 3 by 3 matrix. So you're going to change that so that it is a 3 by 3 matrix. So your matrix A is now a 3 by 3 matrix. And you're going to go through and type in all of your, you're going to type in that matrix A into it. So 1, 1, 6, -1, 0, -2, 0, -1, and -3. And from there, when you're done, you're going to press, you have to make sure you do one huge thing for me. You got to press enter after each entry. So make sure that you press enter after each entry. All right. Where people forget to press enter the most is the entry in 3, that very last number you plug in. So you're going to plug enter. And so once you have them all in there, so you have every entry in there, now you're going to, now we're able to go ahead and move a little bit forward here. So we can get off that screen. So you're going to go and quit off that screen. And in order for you to quit, you're going to go second again. And you're going to type in the mode. So go ahead and get off there. All righty. So what I'm going to have you guys do is we're going to actually go through and multiply these together now. So now that you have that in there, all right, we're going to go through and multiply those together. So you're going to go second. X to -1. And this time, we want that names. Actually, no, I'll just make you come up with the inverse. I won't make you multiply them together. So we're going to go ahead and make that names 1 show up. So we got names, we got math, and we have edit. So under names, we want that one right there. And what you're going to do here, friends, under number, that was the weirdest looking one again. Under 1, you're going to make sure this one's highlighted, and you're going to press enter right beside it. Once it's highlighted, press your enter button. Well, it'll already be highlighted for you, so you just got to press enter. And what's going to happen is you're going to get this to show up. So that will now show up on the main screen. So you're going to go ahead and you are going to then go back and press Once you press enter, you're going to go back and press your inverse button now. And what that's going to do is that's going to make the inverse button show up. So now once you have that, go ahead and press enter. And make sure that you actually got your inverse to show up. -2, -3, -2. -3, -3, -4, and 1, 1, and 1. All right, so that's how you guys are going to use your calculators. And now we're going to use our calculators to do our final thing of the day. So they give you an example here up here on how to go through and solve a system. All right, on how to solve a system. So I'm going to go through it a little bit with you as well. But I'm going to give you a different system because I want you guys to play with these ones here. So say I give you a, that's not what I wanted. There we are. Say I give you a different system. That's what I want. I need that mouse back. Okay. Say I give you a system like this, x minus 2y plus 3z equals 7. And again, we've already solved this one. I want you to see how this works. 2x plus y plus z equals 4. And negative 3x plus 2y minus 2z equals a negative 10. So what we're going to do, usually we do an augmented matrix. We're not this time. What we're going to do is we're going to have a coefficient matrix. We're going to have equal to a variable matrix, or times a variable matrix, and equal to a solution matrix. So we're going to take all the coefficients on the left-hand side, and we are going to write them together. So we have 1, 2, negative 3. Those are all my x's. I got negative 2, I got 1, and I got 2. Those are all my y's. And then I have 3, almost 3, 1, and negative 2. Those are all my z's. So I have my coefficient matrix. And I'm going to multiply that by my variable matrix, x, which is x, y, z. And when I multiply that, friends, that should end up being equal to my solution matrix, 7, 4, negative 10. So what we're going to do here is we're going to take our inverse matrix, or that inverse of our coefficient matrix. So you can shorthand this eventually if you want to. So I'm going to take that 1, 2, 3. Negative 2, 1, 2. Three, 1, negative 2. And what I'm doing here on this is I'm going to do the inverse of that matrix. So I'm going to create on this left-hand side the identity matrix. So 1, 2, negative 3. So I'm going to make these go away where I'm only left with my solution or my variable matrix on that side. 3, 1, -2. Now I need my green one. Whoop. X, Y, and Z. So that didn't really come out all that well on that screen, did it? And when I multiply the inverse matrix on one side, I'm going to multiply it by the other side. So I get my 1, 2, -3. I get -2, 1, and 2. And then I get 3, 1, and -2. So this will be the only time I really write out the entire thing. So I usually leave out this step that I'm currently writing. I'm doing this 7, 4, and -10. So now I end up with my variable matrix by itself. Because it is getting, on the other side, I'm having my inverse matrix multiplied by my solution matrix. So 1, 2, -3, -2, 1, and 2, 3, 1, and -2. So now, friends, this is what I'm going to plug in my calculator. So I'm going to plug in these two matrices, and I'm going to multiply them together to get my answer. So this is going to be my matrix A. And then I'm going to type in the inverse button after it. And then this right here, I'm going to actually type in as matrix B. So matrix A, inverse matrix B into my calculator to actually get the actual answer I want. And when I plug it in there, what I'm going to end up with is X, Y, Z. Is going to be equal to whatever that result is. And that result in this case would be 2, -1, 1. 2, -1, 1. So it means X is 2, Y is -1, and Z is 1. So that is my solution. All right, so that's where we were building up for today. How do we use these now in an applicable way? Now, again, I don't usually write this row here, that line, when I'm solving it. You can if you want to. I just know that when I multiply the inverse, it's going to go to the other side. So that's usually where I go with it. So you guys can skip that line too if you wanted to. All right, why don't you guys try, go ahead and pause the video, try number 4, and let's see how you guys deal with it. Right? Use inverse matrices to solve it. All right, let's see how you do. First of all, let's set it up. I see 1, 1. I got all these 1s here. 1, 1, and 2. So that's my coefficient matrix. I have my variable matrix, so you got to always set it up, X and Y. And that equals my solution matrix, 7 and 11. Yeah, that's my wife and my birthday, or birthday anniversary. Take her there every year and go get snow cones or Slurpees. That's not true. That's not true. No Slurpees. All right. So if we move that now to the other side, I get 1, 1, 1, and 2. And when it goes the other side, it becomes the inverse matrix. And now we plug it into our calculator. And I'll have my variable matrix by itself, so X and Y. When those get multiplied together, I should have for myself a good answer. In this case, that answer would be 034, which means that X is 3 and Y is 4. All right, I know we're approaching the hour mark here. I told you guys this was gonna be a long one. Here we go, last one for you. Last one, we're all done after this. All right, try this one. Go and pause the video and then we'll solve it. All right, here we go. I see some ones here, so I gotta put some ones in front of that. So I got a 1, 1, 1, 6, -4, 5, 5, 2, and 2. So we end up then with X, Y, Z. And that's going to be equal to our solution matrix, 2, 31, 13. Okay. We move to the other side using our inverses. So I have X, Y, Z. That's going to be equal to our coefficient matrix. The inverse of it is 1, 6, 5, 1, -4, and 2, and 1, 5, and 2. All right, so there we can do our inverse matrix of that one. We're going to multiply by the 2, 31, and 13. That will bring us our final answer, X, Y, Z. When we plug that into our calculator, we end up getting 3, -2, and 1. So these inverse matrices, especially when we have our calculator, computer software to solve them for us, they actually go pretty darn quick, don't they? 3, -2, and 1. And friends, that is our final answer, 3, -2, and 1. All right, you guys are troopers. I knew this was going to be a long one. I appreciate you guys hanging out with me. All right. So enjoy the rest of your afternoon, evening, and I'll see you in the morning.